This will be probably the hip ROM, biaxial hip ROM thigh. Um, this is the Mechatronic system. I'm applying a toilet, and this is the seating area. However, I would have to apply another additional segment. This is not limited to this structure. Subject to additional structure. I also apply the tubing around the inside of the cone, rubber cones, synthetic rubber. I have to pour substrate. I have to pour epoxy resin crystalline to create a horn-like toilet for this system. I have a tube running alongside to where it's blocked for holes that will be punched into it to bleed into the shaft area to drain the stool. However, the rubber is just only the alongside mount. It's just a dressing. However, the inside would have a cone-like shape shaft for the stool defecation. I'm also going to apply the urinal section here, powered by a servo to function as a gripper towards the groin area. I have the Biaxial ROMs all banded up until then. I also have the process of the vertebrae lower back. The rotary the rotaries, series of rotaries that I'm going to add to it. This is not the rotary. A beam grinder is to be added to this with an open clearance that just sits with the blade within the center shaft like this inductor fan. And what it does is it grinds up the stool and vacuums it and dispatch it inside of a tank, which is small as a gas tank to a weed whacker. Miniature motor gas tank. So it's very small and it will cause the stool to go down. So I'm going to fill this with a crystal alongside leaving it an open shaft with epoxy resin crystalline hardener. And that should make a nice little appearance of it. I'm also waiting for my photosensitive sheet as far as my circuit modular, but I'm going to be using light sensors and PIR light sensors and basic motion sensors, so that when the stool is being exerted, it would automatically flush to vacuum. However, we would continue to vacuum in light, but because of the image being sensed, it would cause the flush to be more stronger, to pull the stool down through the blender to blend it into liquid formula to allow it to be dispatched into a tank, sewage tank within this robot system that I'm making. This again subject is not limited to additional structure. The rotaries on the back, I'm gonna add more rotaries, and that's why I brought up the subject to the rotaries, because there will be more. Now this is the butt part of the unit. See, fans, these blades will be changed. The only temporary setting of the same, similar to the same, but they will be in iron. The butt system has the open clearance for that. It does have the Biaxial ROM in the front. So I'm still working on the segment, and I will continue until I'm successful with the unit, until I feel satisfied. I will be adding additional fans, thrusts, so it can increase the thrust transporting air from one place to another. So I will be adding more of these within the chain, and step down ones within the chain for that part. Like I said, in additional, what I think I didn't mention in this video was the solenoid holes that connects these parts together to unite the hip along with the abdominal waist, and process of the continuating chain linkage process of the vertebrae of this mechatronic system, wearable exoskeletronics. The brackets are very temporary. See, I have a gorgy material of metal that I'm going to be cutting and making better horns for the servo. This is aluminum. It's very thick, very thick and very hard. I think it would be hard to bend deformation very easily in the human body. In addition to that, remember that these servos are just a temporary. I'm going to, if I didn't tell you, now I'll tell you. I'm going to be upgrading to 120 kilograms servos. These are only 60 kilogram servos. So I'm going to be upgrading for the hip thigh Biaxial to the 120 kilogram servos. And I don't know what more to say. This is going to be like the seating. I think I'm going to give you a nice jelly interior. The Biaxial, even though this turns this way, I have it belted with tightness to hold the cables from being all over the place. That will have a wooden exterior, so it allows it, or either wood, or I'm going to be using iron, to have exterior to allow the cockpit part of the legs to move on top of this surface, so it may move and correspond alongside it, not just according to the exterior, to where I could have placed this on the back, but it would have been too far back. And even though it would have moved the leg, but I want it more close to the body, where I can section according to the biometric range. As a cockpit itself, powered it by two different sections and stages. One, the first stage, which is the rotary stage. This is also to help with fixed gyroscope and stabilization. It's also to help with propulsion. Second stage, which is the biomechatronic system, which is the extremity, which enables the body to lift the body as a human actuator, or humanoid actuator, as a human actuator, as a human mover. Now, as for other means of gaining energy, I'll probably also be using some rocket materials. And I'm using a spool lead rocket in exchange of the conventional rockets that are cylindrals. This is where I'm using a spool wire type tubing to ignite, and it would take a long time. And where the inertia is more faster and quicker in an environment of coldnesses where the air expands in such extreme heat. Dispatching out of different areas. So other than the section of rotary, I'm also going to be applying gimbal motors, other hubs alongside within the exterior of the housing. The reason why within the interface of the housing and the exterior, the reason why is because it's to also add a gyro force and energy. So anytime, whether the rotary's propulsion is running or not, still the kinetic energy that is being produced through the gyro will enable this device to be fixed in proximity, and using a DC and a dead motor also to drive it, allows synchronizing to capacitor and lithium to recharge the gyroscope. So hopefully I can keep the gyro functionality in a perpetual motion to constantly auto recharge and to cut off and to save the energy by producing energy and also reducing energy in other places where it's necessary. Now, the housing exterior is a waffle housing that I'm going to be using for this drone suit, which is like similar to a 9-man Mark 42. In similarities, I didn't know if he had a toilet, but as far as Mark 1, I believe Mark 2, I believe that he had a toilet in one of his. So I intend to apply that same strategic method and approach within my system. And my name is Jermaine Morgan, and goodbye. I'm making a vacuum system within to grind, also to blend up the stool to convert the density into liquid fluid as far as the stool. This will use an articulated zigzag having that's the shoulder, that's the chest, and this is the back brace. Again, I'm going to be using the vertebrae process angular, so this is the vertebrae process, and I have to go back to it to finish. This is as far as the neck. This is tilt. This is pan. This is tilt in a different direction. I need in between this part of the tilt, I would need an angular tilt, one towards the left, angular, and an angular in a crisscross like an X to where the U brackets are crossed like an X. So that's going to be right here in this section right here, and the pan is going to be localized down there a little further. So that's going to be done in the morning of this cockpit. I have the hub for the leg Biaxial ROM. This is for the horse, the servo for the horse. This is for the split. This is for the release. This from release a person from the cockpit as far as the door open servo. This is for the stool part for the buttocks. This is the urinal part to roll up towards the urinal area. This is the chest part of the segment, and this is the shoulder part of the segment. These all are drones. They incorporated into one, so I'm just doing it set by set. I have to do the legs too, so I'm going to be back with that later on. Goodbye. The system is supposed to have a vacuum. It's a climbing vacuum, and it has these gears, these servos as claws to claw on to grip as grippers, and vacuums are the sections of the shoulder, so one could apply their arms upward. However, these fans will be mounted with it will have a gate over it to protect it. Now, vertebrae process. the Biaxial ROM, hip Biaxial ROM, Biomechatronic, and the toilet. And I will apply the proportion of the linkage within a chain of servos. And this is the back. This is the level. One level is Biomechatronic, another level is rotary. This is shaped as a human buttocks. Butt. So I would have to move this system over to open it. Oops. I have one hand holding the camera, forgive me. Break. Okay. This is the back of the system. Right here. And